Okay, welcome to Chapter 15. Now, an awful lot of Chapter 15 is a review of what we already should have learned from the Java class, so we're going to add some extra stuff at the end. All right, so Chapter 15, page 337, it's on arrays, array list, map, and random numbers. Okay, so starting off at the beginning, they talk about random numbers, and again, hopefully this is a repeat. So if I want to generate a random number for some sort, well, first of all, I guess I'm going to have to create me a playground, so to speak. So I'm just going to grab me a text guy and multi-line and just drop him here so I can just display some stuff. And of course I'm going to rename him. He's going to be edit text display. Yipper. And let's go ahead and have him consume the whole thing. Because that's the only thing we're going to have going on. Okay, now back to the story. So I want to go in here and I want to create a random number. So it's a class. So that means I need to have a new operator to instantiate a new class. So I just say random and then give it a variable name. I usually just call mine something simple like R is equal to new random, like that. Okay. And then after I tell the guy where to find these guys, boink, I now have a new random number generator. Okay. Now, now that I have a random number generator up and running, how do I get it to produce something? So if you're producing integers, for example, so I say int junk is equal to r dot, and let's look at all the stuff. They have next int, which is a pretty cool one. And then I would say, give me the next int in the list of random numbers, right? And then you could give it the upper bounds, like 100. Now this is kind of weird because almost all of the random number generator libraries that I've seen, when you say upper bound, that's not inclusive, which means this is going to give me between 0 and 99. If I wanted 1 to 100, well then I'd have to do something different. I would have to go in here and manually add an extra 1 in here. So it's already going to give me 1 to 99, so adding a 1, obviously. So this would be between 1 and 100 inclusive. Okay, so in order to get it to make any sense, you basically have to just make sure that the upper bound is not inclusive, and therefore you have to make some tweaks. Okay. Again, hopefully this is, normal, right? I'm going to go ahead and display it. So let me go ahead and I'm probably not going to, I'll do this the same way I always do. This would be, edit text display. Oh, sorry, hang on. If I could spell today, I'd be in good shape. Edit text, et display, and then down here some places where I would go and instantiate that guy. Et display is equal to find, and then r dot id dot et display. Cool. All right. Now back to the story. So I just want to display this on the screen. Nothing fancy, right? So I'm just going to say, et display. I'm going to go ahead and use append. And then I'm going to say I want junk. And then I want to add a new line onto the end of it. So, okay. So let's just make sure this thing works. So this should generate us a random number between 1 and 100. And it came out 2. Cool. All right. Fairly straightforward. Okay. So the next thing we're going to talk about is just plain old arrays on page 378. So philosophically, an array is just technically it's called a data structure, but it's really just a convenient way of collecting related things together so that you could operate on them in a hurry. I mean, if I had 15 variables, I could just call them one of them, variable 1, variable 2, variable 3, all the way down to variable 15. But that's kind of annoying. When you put this in an array, it actually makes it a little bit faster, and we'll explain why in just a moment. So I'm storing a bunch of stuff of the same type. Now I can't store integers and strings and doubles in the same array. So the type of the array determines what it stores. Okay. Now these things could be complex things. They could be employee instances. They can be integers, right? They could be anything. So to create an array, you basically just use a square bracket. I'm going to build one that's designed to store integers. So square brackets. And this is going to be, I don't know, my number list. Something, I don't know. I'll call it number array. And then, since all arrays are reference types, I have to have a new operator here. And this time, I'm going to tell it how many I want. So I don't know, I'm going to want 25. Like that. Now, arrays are reference types. You can kind of sort of tell, just like this guy was a reference type because of the new operator. However, what it stores could be a reference type, or it could be what's called a value type, like an integer. So in this particular case, I'm storing integers, which are not value types, inside an array, which is a value type. I said that wrong. I'm storing a value type inside an array, which is a reference type. Boy, I hope I didn't confuse you there. Okay, so I can obviously build any, instead of int square brackets, it could be string square bracket or employee square bracket, right? Doesn't matter. It's all the same. Okay. So how do you talk to a particular element inside the array? So now that I have this thing, now I switch the square brackets over to the variable. So when you build it, typically you put the square brackets onto the data type. By the way, that's not how C++ does it, and Java will actually allow you to do it the other way around. I'm just saying that's not the way I do it. But now I can go in here and say number array, and now I do have to put the square brackets here. And then I can put in here and say 12 is equal to, I don't know, whatever. 1. Okay. So that means this value of whatever the heck that is, 22,000, blah, 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 is going to go into the 12th spot in my array. Now, I only have 25 spots, and the spots are numbered 0 to 24, right? So I can't say something like this. That would freak it out. In fact, hey, let's try that. Let's just run it and see what happens. Bonk. Killed me. I mean, killed my entire dang application. Well, that's not very nice. So clearly, you can't have this thing run off the edge, so to speak, because an array that has 25 spots is numbered 0 to 24. Cool. All right. So now this thing here, does it have to be a constant? I mean, couldn't I just say something like int index is equal to 12 and then turn right around and do something like this? I mean, does that work? Of course. Let's make it even more complicated. Let's say I have something like index, I don't know, plus plus. Does that work? Well, yeah, as long as you don't exceed 25, you're okay. Okay, so the thing, it's called typically this is called an index. The thing inside that tells you where you are in the array is called an index. You don't have to have a variable called index, but it kind of sort of makes sense. Okay, good. So let's say you built this thing way on, and you can't even remember how big it is, or maybe you were past an array and you don't have any idea of how big this guy is. So let's just see how big this guy is. So I'm just going to say et display, and then I'm going to say append, and then I'm going to do number array dot, and one of the fields is length. Now this is kind of weird, and I don't really understand it, to tell you honest to God truth. But they decided not to use this like a getter, so it's just a field, right? Just a plain old field. Let's go ahead and put some more words in here so it makes some sense. Okay, so this should give us what, 25, right? That's the size of this guy. And yep, the length is 25. Hooray! Now, because it's a field, does that mean that I can go in here and change it? I mean, if this was a getter, certainly you could not turn right around and change that. Let's just try it, okay? So I'm going to say number array length is equal to 26. And it goes, no, man, we ain't playing that game. So this is a read-only field. Okay, just saying. Read-only field. All right, so there are also some really cool, useful things you can do. There's an array fill operation and an array sort, and there's a lot of cool things using the static methods of the array class, array dot. And then you can say, get me something, set me something. I do all sorts of cool stuff in here on how to get things done. Okay, oops, it's arrays plural. So there's an array fill, an array sort, right? I can go in here and say, well, I want to sort this guy. And this guy, of course, is number array. So lots of cool little extra methods in here. I just mentioned sort and fill. There's a gazillion other ones, as you just saw. So this is a static class. The arrays, plural, is a static class. Kind of cool. All right, I'm going to skip a bunch of stuff when they start talking about getting dynamic with arrays and dynamic array example. Okay, that's not really critical for our understanding, and hopefully this is all review anyway, so I'm moving on. Okay, a multi-dimensional array on page 385. This is like an Excel spreadsheet where you have rows and columns, okay? Now, I use that analogy kind of loosely because I don't want you to think about a physical row and a physical column. Although that might be the mental image you see in your head, I'm just cautioning you, don't use row and column to talk about these things. So let's do another one, except this time I'm going to throw in some constants. I typically, whatever I'm doing, multi-dimensional arrays, I love to use constants. I'm just saying. So let's go up here and let's build us a couple of constants. So I'm going to say final int, and let's call this one num students is equal to 12. That's supposed to be final. Okay, cool. And then we'll do another one. Final int num quizzes is equal to 4. Okay, so I typically do this because when it comes time to building a multi-dimensional array, it is often easy to get confused on what axis is what. Is the first axis, which kind of sort of looks like the x-axis, is that student or is that quizzes? Okay, and so just to make it clear, I like constants because they say what it is that they're doing. So okay, let's just build one then. So I'm going to build me one called double, and this is going to be grades. And it's going to be equal to a new double, except this time I'm going to say num students, and then the other square bracket, actually, let me fix that, num quizzes. I really need 2 square brackets here to show that this is a 2-dimensional array. Now, I'm not going to get into too much details, but I'll just give you a hint. The way Java does 2-dimensional arrays is not at all common. The more sophisticated language, that's a slight. Other languages do it slightly better, where they actually have real, honest-to-God, 2-dimensional thing. This is what in the other languages would be called a ragged array, but don't worry about it. That's not really all that relevant. I just wanted to mention it. And, of course, we're coming up on the 15-minute mark.